So those first 4 problems are a little easier. They do get a little more challenging. On the next set, the book goes ahead and gives us mixed practice. Now, these could be anything. They might be triples, they might not be. Quickly, if I look at this first one, I can see that 3 factors out of 9 and 13. 9 and 15. 3 times 3 is 9. 3 times 5 is 15. So that's going to be a scaled version with 3 as the scalar of a 3, 4, 5. So I would note that. And then the missing side is the scaled version of 4. So 3 times 4 is 12. And on a test, that is how I would want you to write that out. Let's take a look at one more. So here we have 2 times 3. Here we have 2 times 4. Often, students, when they first see this problem, instinctively say the missing side has to be 2 times 5. However, we need to always remember that the largest side is across from the right angle. The hypotenuse is always the largest side. So the leg cannot be longer than 8. But our scalar here is 2. 2 times 3, and then the unknown side, and then 2 times 4. We really don't know if this leg is smaller than 3 or larger. And again, as I said in the very beginning, it doesn't matter which one of the legs comes first. It absolutely does matter that the hypotenuse, the longest side, is last. And that's because we're going to get a little fancy here. Inside the parentheses, we're going to note that 3 squared plus x squared, our unknown side, is equal to 4 squared. Now, 3 squared is 9, x squared is x squared, 4 squared is 16. Moving over, I have to subtract 9 from both sides. So now x squared is 7. 16 minus 9 is 7, which means that x is the square root of 7. Remember, when you have an x that's squared, to solve just for x, you need to take the square root of both sides of that equation. Now, I need to make sure that my final answer is 2 times the square root of 7. X was the square root of 7, but we need the scaled version of that, which is 2 times that. When you use the reduced triangle principle, in almost every occasion, your radical will be in simplified form. That's one of the benefits of the reduced triangle principle. If you have any questions, I will be available